Hello everyone, I am Muhammad El-Dessouky. I am introducing tutorial number 7, which is about for loops and nested loops. Question 1. What is the output of the following code segments? This question we have 8 segments from A through H. They are all discussing different cases of for loops. In segment 1, we have a for loop that has only two parts or two statements out of the 3 that is usually we see in for loops. So before we go ahead and discuss what is the output of this for loop, I would like to clarify something. For loop has 3 statements. Let me write this down. Statement 1, and then a semicolon, and then statement 2, and another semicolon, and statement 3. So the first statement here is only you need to know what is the role and when does each of these statements is executed or evaluated. The first statement is used to initialize something called the for loop variable, and this statement is only executed or evaluated in the before starting any of the iteration. So before starting the for loop, we go ahead and initialize this variable. As we can see here, we initialize a variable called I to value 1, and this statement is only executed before running any of the iterations. For the statement 2, this statement is the condition of the for loop. This is the condition that we check every time before any of the iterations. So before every iteration, we go ahead and check this statement. It's a condition, and this condition, if it's true, we go ahead and we execute a new iteration of the for loop. If it's false, we terminate the for loop. So we need to have an expression here that always gives either true or false. For the statement, by the way, statement 2 is optional, and all of these statements are optional. For statement 3, this is a statement that is always an assignment statement where you want usually to modify some variable. So the condition states change based on the variable here, and so and the condition change its value, so you can terminate the for loop. Going back to statement to the segment here, to our segment A, we can see that is only we have the initial statement and the condition, or the statement 2. And the statement 2, the variable is not only used in the condition part, but also we change the value of the I. We have a pre-increment operator for that I, and this so we change the I before, because of the pre-increment operator, we change the value of I before checking the condition, before each iteration, of course. So for the first iteration, we have I equal 1. and because of the pre-increment operator, I increases to be 2, and 2 is less than 4, so we print the first value of I, which is going to be 2, and then we start a second iteration and we check if plus plus I is less than 4. I was 2, and because of the pre-increment operator, I now is 3, and 3 less than 4, so we go ahead and print the value of I, which is 3. For the third third iterator or iteration, sorry, I is going to be 4 because of the pre-increment operator, and because 4 is not less than 4, we terminate the for loop. So let's go ahead and run the code and see that the output there. So the output there is 2 and 3. Segment B. For segment B, it's just a normal for loop where we have the 3 statements here. We initialize I to be 1, and we check if I is less than 4, and after each iteration we increase I by 1. So for the first loop, I is 1, so we print I, so we print 1, and then we increase I, and then I is 2, so we print 2, and then 3, and in the fourth iteration, I is going to be 4, which is not less than 4, so we terminate. So for this for the output of this segment, we're going to have 1, 2, and 3. Let's run this and see the output in Eclipse. Here we go. 1, 2, 3. For segment C, we have exactly the same segment as in segment A, except that instead of having a pre-increment operator for the I here, we have a post-increment operator. So the condition will use the original value of I, and the increase of the value of I will happen after checking the condition, and of course before executing the body of the for loop. So for the first iteration, I is going to be 1, and 1 is less than 4, and then I is going to increase to be 2, and system.out.print will print 2. So the first iteration will print 2, and then the new value of I will be involved in the condition here. So 2 is less than 4, yes. And then we increase I to be 3. 3 is going to be printed out. And then 3 is less than 4. We go ahead and print 4 because of the post-increment operator. So the output here is going to be 2, 3, and 4. Let's go ahead and run the Eclipse. As you can see here, the output is 2, 3, and 4. segment F, we have only for loop here, and then we have a series of if else statements. The if statements check if the number is multiple of 2, 3, or 5. So if the number is multiple of 2, we print out the number plus 1. Else, if I is multiple of 3, we don't do anything, we just continue to the next iteration. Else, if I is multiple of 5, we just break the for loop and terminate it. However, if none of these are true, we just go ahead and print not multiple of 2, 3, or 5. So let's go ahead and see what is going to be the output of this for loop. We initialize I to be 1 and I is less than 9, so we go inside if I modulus 2 equals 0, no, so we go if it I is, or if 1 is divided by 3 equals 0, no. If I has a remainder of 0 if we divide it by 5, no. So we go ahead and print not multiple of 2, 3, or 5. This is the first iteration. Oh. Sorry. For the second iteration, I equal 2, so 2 is multiple of 2, so we go ahead and print I plus 1, which is going to be 3. And then, because it's else if, we going to have a third iteration. We will not execute any of the other parts here, and we will go for the third iteration. In the third iteration, I will be 3 because we increased it. It has a post increment operator. So 3 is not multiple of 2. 3 is multiple of 3. So we continue to the next iteration. So I is going to be 4. 4 is multiple of 2. Yes. So we're going to print 5 because we print I plus 1, of course, here. For the fifth iteration, I is going to equal 5. 5 is not multiple of 2. Else, is it multiple of 3? No. Is it multiple of 5? Yes. So we break the for loop and then we get outside and we print end. So actually the for loop, the program breaks at iterator I equal 5. The loop will end at I equal 5, not I equal 8. Let's go ahead and run it in the Eclipse. As we can see, here's the exam. Is the same output as we saw in our evaluation. segment D. Segment D actually is similar to segment B. However, the only difference here is that in segment D we have a pre-increment operator before the I, and in B we have post-increment operator. However, this change of the operator from post-increment to pre-increment is not going to make any difference. It's not like the difference, or it's not like as we saw in between A and C, where using the pre-increment gives a different output than using the post-increment operator in C. That's because in A and C, the post and the pre-increment operators were involved in an expression. So the I has been evaluated before that expression and after that expression, and this is why there was a difference between the output in A and C. However, B and D is totally different, because I here is executed solely. So it's like the I has been incremented or has been used in a different or as in a separate statement, or without being in any expression. So the output here, let's go ahead and take a look at the segment. So we initialize I with 1, and we check if I is less than 4. Yes, 1 is less than 4. We print I is 1, and then we execute this statement. So in both cases, B and D, we execute this statement after the iteration. So here I is going to be increased to B2. So print, we're going to print 1, and then we print 2 for the second iteration, and 3, and when I increase to B4, the condition will be invalid, will not be valid, and the for loop will be terminated. So let's go ahead and execute that in Eclipse. So the output is 1, 2, 3 as in segment B. Let's move to segment E. In segment E, we have a nested for loop. For the outer for loop, we initialize j to equal 0, and we check if j is less than or equal to, and after each iteration, we increment j by 1. In the body of the loop, we print out j, and we have another for loop. In the inner for loop, we initialized a new variable ch. We initialize it to capital A, and then it's a character. Actually, it's a character variable. We initialize to capital A, and then we have a condition ch less than or equal m. So we check if character or the character here is less than m, and so the condition actually and the comparison is based on the lexicographical value of characters and based on the ASCII code of each characters. And after each iteration, we change the value of ch to be the old value of ch plus 3 plus the value of j, and then we print out the value of ch plus 1 and cast that value to character. And after finishing the for loop, after we terminate from the for loop, we go ahead and print a new line. So let's start and see what is the output of this segment. So let's start with j equals 0. So the condition here is going to be true. So that we're going to print the j value, which is 0 here in our case, and then we go ahead and initialize ch to be capital A, and yes, ch is less than m. The ASCII code of A is less than m. So we go ahead and print the value of ch plus 1, which is, and then cast it into a character, which is going to be the capital letter B. For the next iteration in the inner loop, before starting that, we change the value of ch to be the old value, which was A, capital A, and we add 3 plus j to that. So j is actually 0 because we still in the first iteration of the outer for loop. So we will add only 3. So it will be the value of A plus 3 is going to be we're going to move to the third to move 3 positions after A, which is for the first position after A is B, and then C, and then D. So ch here will be the value of D character, the capital D, of course, in the ASCII table. So we will go ahead and print out the ch, the cast of the ASCII character plus 1, which is going to be E in this case. So we will print capital E. And then we will keep going each time. I mean, for the third iteration, before we start the third iteration, we will add 3 to letter D. So it's going to be E, F, G. So the new value here will be the ASCII value of the capital letter G. G is less than M, so we will go ahead and print the letter G plus 1, which is going to be H. So here is going to be H, and then we will go ahead and until we reach the next. Okay, let's continue. Let's continue. So we print H. And we print H, and after just the iteration, we change ch to be 3, plus G, which is going to be the J letter. So CH will equal the J letter, and see if J is less than M. Yes, it's less than M, so we will print out J plus 1, which is going to be K. So we're going to print K. And then we go for another iteration. Before the next iteration, we change the CH to be J plus 3, which is going to be M, because J value of ASCII plus 3 is going to be the ASCII, the 3 position after the letter capital J. So it's going to be M. And then we check if M is less than or equal M. Yes, capital M. So it makes the condition true. So we go ahead and print we print M plus 1, which is going to be capital N. We just increase CH by 3. It's going to be so MNO P is going to be P. P is not, it doesn't make the condition true, so we terminate the inner. And so we terminate the inner loop here, and we print out a new line. So we go ahead and just press enter for a new line, and then we increase J by 1, so J now is 1, and we print the value of J here, it's 1, and then we go ahead for the inner loop. We start CH variable, we initialize it with A, and then we check if A is less than M. Yes, we go ahead and print CH plus 1, which is going to be also B. So we have B, and then we increase CH to be the old CH value plus 3 plus J. However, in this time J is not 0, it's 1. So we need to move 4 position after A. So we need to be B, C, D, and then E. So the CH here this time will be E, and yes, E is less than M. So we go ahead, we print F. So we go here and print F. F plus 4 is G, H, I, and then J. So no, G, H, and then I. So it's going for so the CH here is going to be I. We print I plus, yes, I is less than M. So we're going to print I plus 1, which is J. So we print J, and then we go ahead for a new iteration, but we change ch to be I, and then J, K, L, M, we were in I, so we're going to increase 1 as J, 2 as K, I, and then M. So M is less than or equal M, so the condition is true. We go ahead and print N. We change the ch variable to be the old one plus 4, which is going to be 4 position after M, which is going to be Q. So Q is not less than or equal M. So we terminate the for loop and we print a new line. For the outer loop, we have a new iteration. We increase first J variable to be 2. 2 is less than or equal 2, of course. So we go ahead and print the value of J here. And we initialize the letter ch to be A. Ch is less than M, so we go ahead and print ch plus 1, which is B, and then we increase ch to be the old value plus 3 plus J now is 2 actually, so we increase ch by 5 positions. So we are actually in A, so we're going to move to B, C, D, E, and then F. So CH will represent the ASCII value of capital letter F. F is less than capital M, so we go ahead and print. We print CH plus 1, which is the next character after F, which is G. So we have G. Then we increase CH to be F plus 5, which is the character. The character 5, the fifth position after F character, which is going to be after F we have G, H, I, J, and then K. So we're going to have K. K is less than M, of course. So we go ahead and print K plus 1, which is the next character after K, which is going to be L. So we print L. And we increase K by 5, so we have 1 position L, M, N, O, P. So the new CH will represent the ASCII code of P. P is not less than or equal M, so we terminate the for loop, and then we have a new line. For the out for loop, J is going to increase to be 3, and 3 is not less than or equal to. So the output, this is the output of the segment here. Let's go ahead and run this on Eclipse. As we can see, here is the output, and let's move to F. Segment G. In segment G we have nested for loops. The outer for loops have initialized variable k to 0, and for the inner loop we initialize j equals 7. And for the outer loop we check if k is less than 7, and after each iteration we increased k by 1. For the inner loop we check if j is greater than 2 multiplied by k, and after each iteration we just remove 2 from the value of j. And inside the inner loop we print out the difference between j and k, so j minus k, and then we add a plus after that. And for each iteration, we just sum up this difference. And after terminating from the inner loop, we just print a new line. And after terminating from the outer loop, we just print out the summation, the one that's here. So it looks like this variable just sum up all the differences for both values of k and j, and it prints the difference between these two variables. So let's go ahead and go through these two for loops. So we start as k equals 0, and then inside the outer for loop we immediately start a new for loop where j equals 7. We print out a space, and then j here equals 7 minus k, which is 0, so the value is going to be 7, and then there is a plus here, so we add a plus, and then we add the value of the difference to sum, so sum is going to be 7, and we start another iteration, and we update j to be 5 because j minus equal to, and then we check if 0 is greater than 2 multiplied by k. 2 multiplied by k is 0, so, and j is 5, so the condition is valid. So we go for a new iteration, and we print out space and the difference of j minus k, which is 5 minus 0, which is going to be 5, and then we add a plus, and the summation going to be 5 plus 7 plus 5 here. We update the summation to add another 5 to the total of summation or sum. We update j to be 3, and we check if 3 is greater than 2 by k. K is 0, so yes, the condition is true. So we go ahead and print space, and then 3 minus 0 is 3, and then we add a plus to the end. And we go ahead and update sum here, and then we go for another iteration. J is going to be 1 because we just subtract 2 from that, and 1 is greater than 2 multiplied by 0. So we go ahead for a new iteration, and we print space 1 minus 0 is 1, and there is a plus character. We update the sum and we add 1 to that. We subtract 2 from 1 is going to be minus 1, and minus 1 is not greater than 2 multiplied by 0, because 2 multiplied by 0 is 0, and it's minus 1 is not greater than this. So we terminate from the inner loop, and we add a new line. So we go there and we add a new line. We increased k to be 1, and we check if 1 is less than 7, yes, so we go and do that for the inner loop. However, this time k is going to be 1, so 7 is greater than 2 multiplied by 1, which is 2, yes, so we go ahead and print a space, and the difference between 7 and j actually is 7, and k is 1, so so the difference is going to be so j here actually is 7, and k is 1, right? So 7 minus 1 is 6, and then we print a plus. Sorry for that, I mean, I got confused a little bit. And then we update the sum to add, and we add 6 to that. We go for another iteration in the inner loop, and we add we subtract 2 from j, which was 7, so j is 5. 5 is greater than 2, yes, so we go and add a space and the difference between j and k. J is 5 and k is 1, so the difference is 4, and we add plus sign here. We update the sum and we add 4 to that. We subtract 2 from j, so j was 5. 5 minus 2 is 3. 3 greater than 2, yes, so we go ahead and we print the difference between j and k. So 3 minus 1 is 2, and then we add the plus, and then we update the summation or the sum variable. We update j, so j is going to be 0. It's going to be 1, sorry, because it was 3. So j minus 2 is 1. 1 is 1 greater than 2 multiplied by 1? No, so we terminate the outer for loop and we have a new line. For the outer iteration, we increase k to be 2, and then we go for another iteration. So j is equal to 7. And k here is going to be 2, as we said. So j is j greater than 2 multiplied by 2? Yes. So we go ahead and print space. J is 7. 7 minus 2 is 5. And we update the sum here. And then we have a new iteration, and j actually equal to 7. J here, 7 minus 2 is 5, so j now is 5. 5 greater than 2 multiplied by 2, yes. 5 is greater than 4, so we add space, and then we the difference between 5 and k, which is 2, is 3, so we have 3 plus here, and then we update the summation to be and add 3 to that. We update j to be 5 minus 2 is 3, and 3 is not greater than 4, so we terminate the loop and we print a new line. We go for another iteration where k is going to be 3 this time. J is 7, initialize with 7. 7 is greater than 2 multiplied by k, which is 3, so j is greater than 6. Yes, 7 is greater than 6, so we print out space j, which is 7 minus 6 is actually no, j is 7, k is 3, so 7 minus 3 is 4, so we have 4. And we update the sum and add 4 to that. J is going to be 5. 5 greater than 2 multiplied by 3, no, so we terminate. And we have a new line. Actually, yes, we have a new line. A new iteration for the outer loop where k equal 4. We go ahead and check if 7 greater than 2 multiplied by 4, which is 8. No, so this is false. So we don't have any iteration here, so we go out and have just a new line, and then go for a new iteration where k equal 5, 7 is greater than 10, no, so we only have a new, we don't have any iteration for the inner loop, so we only have a new line. We go for 6 because 6 is less than 7, so we go here, we initialize j with 7, 7 greater than 2 multiplied by 6, no, so this is false, so we don't have any iteration. We print out a new line, and that's it. K is going to be 7, and 7 is not less than 7, so we don't have another iteration in the outer loop, so we print out equal a space, and then equal, and then a space, and then the summation value. So if you just sum up these numbers, you're going to have 40. So let's go and see and run the snippet here in the Eclipse and see if it has the same output as we got here. Yes, so as you can see, let me expand this a little bit. As you can see, we have the same output as here. 1, 2, 3, 1, 2, 3. It's exactly as we just calculated or evaluated. Question number 2. Assume the following program. Here we have A, what is the output of this program, and B, if we replace the 4 with the following lines, these two lines, will the output be the same? If the output will be different, what will it be? Okay, so let's answer the first part here. To answer the first part, we need to go through the line. We here have 3 variables, prev, and prev, and sum. We initialize prev with 2, prev with also 2, and sum with 0. So word of advice is that when you try to trace any program, you need to have to write down the values of your variables down, so you can know at which value your variables are. So let's have, so here we have 4 variables, prev, and sum, and the I. So let's write them down. Let's take them from here, and the I also. I, it's not initialized yet. So once we initialize the variables, we go through the for loop. I is 1, so let's put I is initialized with 1, and then I is less than 4. 1 is less than 4, so we update sum to be prev plus prev. So prev actually is 2, and prev is 2, so the summation will be 4. And then we print out the 3 variables separated by spaces. So let's print, let's have the output here. Prev is 2, and then space, prev is also 2, and then space, sum is 4. And then we update prev to be prev, here previous 2 and previous 2, so there will no be change. There's no change in the variable value here of prev, and prev is going to be the sum. Sum is 4, so we update prev to be also 4, and then we update I because we just finished the iteration, so it's going to be 2. 2 is less than 4, yes, so we update sum to be summation of prev and prev, so 2 plus 4 is going to be 6, and then we print out a new line with the values of the 3 variables. So we have 2 space 4 space and 6, because 2 here, 4 and 6, and then we update prev to be prev. So prev is going to be 4, and prev is going to be sum. So sum is 6, so we update prev to be also 6. And then we update, after this iteration, we update the I to be 3. 3 is less than 4, yes, so we go for one more iteration. So the summation is sum going to equal prev plus prev, which is going to be 4 plus 6, so sum will be 10, and we print out the values here. It's going to be 4 space 6 space 10, and then after the iteration we update I to be 4. 4 is not less than 4, so we terminate the for loop, and this is our output here. So let's run it in Eclipse and see if we got the right answer. Yes, so exactly as you can see, it's exactly as the answer we had. We did it ourselves. Part B. So if we replace the 4 with the following lines, so if we replace it with this, what would be the output? And if we replace it with the second one, what would be the output? Is the output going to be the same or no? So let's take this first line and replace it, and let's comment out this line and have it. So as we discussed in question 1, we already saw this this structure in question 1. The problem is that I already starts, it does not start with 1 as in the previous one. It starts with 2, because once you initialized I with 1, the first thing we do is we check the condition, and even before we check the condition, because this is a pre-increment operator, I will be updated with the new value right away. So the I will start with value 2, and that because we started with 2, the number of iteration will be less 1. I mean, because we had a 3 iteration, now because we started from 2, we're going to have only 2 iteration. So let's go through the code and see what would be the output. So we still need our variables here, so let's just start with the initial values of let's even I remove its value, and let's go through the for loop. So int I is equal 1, so I is initialized with 1. However, plus I is it less than 4 or not? So plus plus I will automatically first thing it will increase it by 1, it will increment it, so it will be 2. And then we ask if 2 is less than 4. Yes, it's less than 4. So so the summation would be prev plus prev. So the summation would be 4. And then we print out the values. So it's going to be 2 space 2 space 4 and a new line. And then we update prev to be prev. So prev actually is the same, and prev is updated to be the value of sum, so it's going to be 4. And then we update, and we don't update I here because the third statement is not specified. In this case, it's empty. So the update of I happened when we examine our condition. So we don't update here the 4, the I. So we go and start with the condition is plus plus I is less than 4. So I was 2 here in our case, and because of the pre-increment operator, it's going to be 3. Is 3 less than 4? Yes. So we update the sum to be the summation of prev and prev. So summation is going to be 6 here in this case, and we print out the values. Prev is going to be 2, and then space prev is 4, and then space and summation, and then 6. And then we update prev to be prev. So prev is going to be 4 because prev here is 4, and then prev is going to be the value of sum. So it's going to be 6. Yes. And then we start a new iteration. We ask is plus plus I less than 4? Plus plus I was 2. No, I was actually we didn't update this from the last iteration. It should be 3. So is plus plus 3 less than 4? Plus plus 3 is going to be 4. So 4 is not less than 4, so we terminate. So we only have this is as an output. I mean, comparing to this, we had 3 iterations, so we got this output. Instead, we got only 2 lines here. So let's run it on Eclipse and run the program and see what would be the output. Yes, exactly as we got. So what about the other line, the second line? What if we used this for loop or this for here? Okay, so let's comment this out and use the third one here and see. So the increment here, so the only difference between the first one and the third one is that I is incremented using a post increment operator. However, in the third line, the increment is done by pre-increment operator. However, because the increment operator is only evaluated after the iteration, so increasing and I is not involved in any expression, so there won't be any difference between the first one and the third one. However, let's go through the code and make sure of that. So we need our values, our variables, and let's just put the initial values of these, and here. I just initialize with 1, and then 1 is less than 4, yes. Summation of prev plus prev, or the summation, so it's going to be 4. And then we print out the 3 values. So let's print 2 space 2 space 4 and new line. And then we print prev with prev and prev with sum. So prev is going to be same, prev is going to be 4, and then we update I, so it's going to be 2, and 2 is less than 4, yes. So sum is going to be the summation of prev and prev, so summation is going to be 6. And then we print out the 3 variables. So we print out these three values here: 2 space 4 space 6, and also a new line. And then we after the printing, we update prev to be prev. So prev is going to be 4, and prev is going to be sum. So we update this to be 6. And after the iteration, we update I to be 3. 3 is less than 4, yes. Summation is sum is the summation of prev and prev. So the sum is going to be 10. And then we print out the 3 values: 4, 6, and 10. We update prev to be prev. So prev is going to be 6, and prev is going to be the sum, the value of sum, which is 10. And then after the iteration, we update I to be 4, always after the iteration, immediately. So 4 is not less than 4, so we terminate, and we got this output here. So the output of the third 4 is exactly the same as the first one here, and that's because the pre increment or the post increment, and they are just happen to be evaluated in a separate line. They are not involved in any expression. So there is no difference between having a pre increment or a pre decrement against a post increment or post decrement, because they are not involved in any expression. So finally, let's run this in Eclipse and see the result. Does it match our answer or not? So yes, it matches our answer. Question 3. Write a program to compute pi, where pi equal 4 multiplied by, open parentheses, 1 minus 1/3 plus 1/5 minus 1/7 plus 1/9 minus 1/11, and so on. First, A. Use a for loop, 10,000 iteration, and remainder symbol to find odd numbers. B. Use a for loop of 10,000 iteration, but don't use the remainder symbol to find the odd numbers. So let's go ahead and start. So as you can see, there is 2 patterns here in computing in how to compute the pi here. So first, there are minus and then plus and then minus and then plus and then minus. So the sign alternate between the fractions, and then you can see that this is actually could be can be represented as 1 over 1. So here we divide 1 over odd numbers. So 1 over 1, 1 over 3, 1 over 5, 1 over 7. So when we try to solve such a problem, let's start with the simplest thing. Let's start with writing down the for loop. So the question actually is requiring us to write a for loop of 10,000 iterations. So let's write a for loop with int I equal 0 and I is less than 10,000 and I plus plus, and let's have curly braces here. You can start with 0, or you can start with just 1, but you need to make this less than or equal, so you can have exactly 10,000 iteration. And so, and let's print down the numbers we get from the for loop here, the index of our for loop. Okay, as you can see, we printed numbers from 1 until to 10,000. Next, as you can see, we here only have odd numbers, so let's use the modulus operator to just print out the odd numbers. To get the odd numbers, we just need to use to get the remainder of the index I, and remainder when divided by 2. If it's equal 1, that means it's odd number. So let's print down this one. So you can see we just printed 1, 3, 5, 7. Let's put this around curly braces because we will have multiple lines inside f. And to get the fraction, we just need to divide that by 1. So 1 divided by I, this is the fraction. However, this might not get you the expected result, because I actually is an integer and 1 is an integer, so the quotient, the number, the outcome of this operation will be also an integer. So you're gonna get a lot of zeros here, except the first, because 1 over 1. So to solve this, you might need to put 1.0. So as you can see, these are the fractions. However, we need to sum them up. So let's have a variable and call it sum and make it double because of the division is not. We need it to be double, and let's accumulate the summation over this of the previous results. So let's this will get us the summation of 1 over 1, 1 over 3, 1 over 5. However, we don't need the summation. We need to have the first one to be positive, the second to be negative, the third to be positive, fourth, and there's a pattern. So we might use a flag to determine when to use a negative sign or a positive sign front. So here let's have a double, oh no, not a double, Boolean, call it, okay, let's call it sign, and this should be true, for example. And if it's true, if sign is true, let's add the positive value of this fraction, else we need to add the negative value or subtract it, subtract the positive value from there of 1.0 over I. But we also need to alter or toggle the value of sign for in each iteration. So after just so we might need to write down after each iteration we need to just alter the value of sign to be the opposite, and okay, and then after the for loop we need to system dot out dot print system out, so standard dot print the value of pi is, and we concatenate summation, but however we need to multiply that by 4 because the formula here is needs to multiply this part with 4. So let's go ahead and run this out and see. So we got the value of 3.14, which is the right value of pi. Okay, so the next part of the question is asking us to have the for loop, but don't use the modulus or the remainder symbol to find the odd numbers. So in this case, if we want to just to neglect this or to remove this, we might need to update I, not just incremented one by one, but we might need to update it like to add to 2 by 2. So let's update I, so can it equals to add 2. So every time, so when I starts with 1, the next value of I would be I plus equal 2, which is going to be 3. So I is going to be 1, and then 3, and then 5, and then 7, and so forth, so on. So we still got the right value of pi. Question 4. Write a program that prints the number from 1 to 10, but for multiples of 3, print fizz instead of the number, and for multiples of 5, print buzz. For numbers which are multiples of both 3 and 5, print fuzz buzz. Use a for loop to solve this problem. To solve this problem, let's tackle it part by part. First thing, let's write down a for loop from to print numbers from 1 to 10 as it's specified here. Print the numbers from 1 to 10, from 1 to 100, sorry. So int I equal 1, then I less than or equal 100, I plus plus, and then system dot out dot print the I. Let's print in a new line. So we printed from 1 to 100, and then for multiples of 3, print fizz. So if the number I, if the index of the for loop is multiple of 3, let's print fizz. So let's have an if condition. If I the remainder of I divided by 3 equals 0, which means it can be divided by 3. Let's print a number. Okay, let's print the word fizz. However, else we print the number itself. Let's try this out. So you can see 1, 2 fizz, because 3 is divided by 3 is a multiple of 3. Then 4, 5 fizz, 7, 8 fizz. But for multiple of 3, print fizz instead of the number, and for multiple of 5, print buzz. Okay, let's see. Else if I remainder 5 equals 0, then we print buzz. Okay, you can see buzz instead of 5, buzz instead of 10, fizz instead of 15 should be actually buzz fizz, because the third part of the question, for number which are multiple of both 3 and 5, print fuzz buzz. Fizz buzz, sorry. So this part is tricky actually. If you just try to put the if condition just after the first two here, you would get a very weird a wrong answer actually. So if we did that and so it's a multiple of 3 and multiple of 5, let's system.out.print fizz buzz. We will never have biz fuzz, and I will tell you now just in 1 second. See, For example, here 15 actually is multiple of 3 and multiple of 5, but you'll never have, because once I is 15, it goes here and it just matches the first case, which is it is a multiple of 3, so it prints fizz and it just go out of the for the next iteration. So to solve this problem, you need to just put this in the first as the first condition to be checked. So you can see that we solved this problem by looking at number 15. We printed out fizz buzz. And that solves our question. Question 5. Write programs to draw the following shapes. Shape A, ear, and shape B. So if you can see, there are 1, 2, 3, 4, 5 lines, and for each line it starts with 1 and then 2 stars and then 3 stars and then 4 stars and then 5. So for shape A we need a nested for loop. So for the outer loop, let's initialize I equal to 0 and then I less than 5, and this this outer loop actually is the one responsible for each line to just move to the next line, and I plus plus. For the inner loop, we're going to initialize int j equal 1. There is no difference if you start or you initialize your variables with 0 or 1. You can use whatever number you want, and inside the body of the loop you can just use the index the way you want. You can just use as this or add 1 or whatever the way you would like to do it. And then j less than 5, or should be equal 5 here, and then j plus plus. So for the inner loop is responsible for the stars in the single line. For one line, how many stars? So for the inner loop, we will just try to print the star character here. If we run this, I think we are not gonna get this shape. However, we will modify it until we got the shape we want. So we just got one line. So we need after each the inner loop, we need to print out a new line. So we to see the shape print line is just an empty line. Let's run again. So we don't have, we got 5 lines, but each line have 5 stars, and that's because the inner for loop print 5 stars. So how do we just make the inner loop depend on the variable of the outer loop? So we need to just use I here. So for the first loop, for the first outer iteration, we need to just print 1 star. So we need for the inner loop to only have 1 iteration. So in this case, if I is 0 and I is 1 and j is 1, j is not less than I, so we will not actually have any iteration. So to modify this, we would need to have 1 here, and we need to modify this to be 0. So in this case, for the first iteration, when I is 1, j will initialize to 0 and j will be less than I, but we need to remove this equal here. So 0, which is here the g or the j is less than I, which is going to be 1, so we will print only 1 star. When I is 2, j will start with 0 and 0 is less than 2, and then we're gonna have another iteration which is j equal to 1, which is still less than 2, less than 2, yes. So we will print 2 stars for the second line. For the third line, for the first iteration of the outer loop, we're going to have 3 here, and we will have 3 iteration for the inner loop. Let's go ahead and run this out. So as you can see, we have the same shape but fewer lines, because here we have 1, 2, 3, 4, 5. However, here we got only 4. So we need to just increase the outer loop, because the outer loop is the one responsible for the number of lines. So we just need to make it equal 5. So because we need 5 lines. Let's run this again. Here we go. We got exactly the same shape of part A. For part B, we still need nested loops, but let's comment this out and have an outer loop for lines. Also, let's take the same information as here, the same line here. And however, if you can notice that the first line have 1 star, however the second has 3, the third has 5, and then 7, and then 9. Okay, how can we compute the number in each star? Because it's not, so the way to do that, there are multiple ways actually. You can just multiply the number of the number of line by 2, and then just add 1 to that. For example, for line 1, or subtract 1, not adding 1. So here, for example, line 1 multiplied by 2 is 2, and then minus 1 is 1. For the second line, 2 by 2 is 4, minus 1 is 3. Here we have 5 stars, so we multiply the number of line, which is 3, by 2 is 6, minus 1 is 5. So let's go ahead and write this down. So for j let's declare this first. For int j equal, let's start from 0, and j less than I multiplied by 2 minus 1 j plus plus. This is minus. So we need to print the stars, and we also need to have a new line after the for loop here. So for each, because this is responsible for a single line, and this is just gonna break them down to lines. So let's run this now. So as you can see, we got exactly the number of lines we need, and also we got the number of stars in a single line. So here we have 1 star, here we have 3, here we have 5, here we have 7, 1, 2, 3, 6, and 7, and here is 9. So however, we didn't get the shape, the pyramid shape we wanted to have. So to do so, we need to add some space. For example, we need to add, if we have this, if we got this shape here, so we need to add 1 space here, and then 2 spaces here, and then 3 spaces, and then here 4 spaces, 1, 2, 3, 4, right? So we can get this shape. How are we gonna do that? So we need another for loop, a parallel one to this, to add the space we want. We might so let's so the first one should add 4 spaces, right? So let's define a new, or let's not necessary, we might use the same variable. Actually, you can use j, and let's j equal 1, and then let's use the index, the outer loop, to compute the number of spaces. So if j is less than or equal 5 minus I, we go and print another space, and then we just increment the j. So actually it's gonna have a problem because we have duplicate variables definition, so we might actually remove this. Yeah, it's going to be fine because we only have one declaration here, and this one doesn't have any declaration. We can use actually another variable name, but it's okay. So let's print out space system.out.print line, and let's have a space. So for the first iteration, okay, I insist to have a single. Let's have int j here. Okay, so for the first loop, loop for the first iteration of this loop, j is going to be 1, so 5 minus I is going to be 4, so we will print 1 space. And then for the second iteration, j is going to be 2, 2 is less than or equal 4, so we're gonna print it, and 3 and also 4, so we're gonna print 4 spaces. For the second iteration of the outer loop, I is going to be 2, so and j is going to start with 1, so we're going to have 1, 2 and 3, because 5 minus 2 is 3, so we're going to have 3 iteration for this. So I guess if we run this, we're going to have the wanted shape. No, we didn't, because we used print line. We just need to have to print the spaces in the same line. Let's go again and run it. Exactly. So we got the shape, the required shape, or the shape we want. Question 6. Write a nested for loop to display the following output. So the output have 5 lines. First line have letters from A to E, and the second letters is from A to D, and third from A to C, fourth A and B, and the last is just A. So let's start first by printing just the first line, and then continue by having the outer for loop that prints all the lines. So for the first line, we just need to declare and initialize a character variable to A, and while this character is less than or equal equal E, sorry, we just increase the character. So let's print this out, system.out.print, and let's print the character. So here we go. So we printed A, B, C, D. However, in the output, the required output, we need to have spaces between the letters. So so we can just add this by concatenating a space here. So here we go. However, so for the other lines, we need to for each iteration of the outer for loop, we need to just change this to be the last character. So instead of E, for the next line, for the second line, we need to have D, and then C, and then B, and then A. So to do that, we can define an integer I as an index and initialize it with 0, and if I less than 5, sorry, because we have 5 lines, I plus plus, and then and then we just subtract I from this E, and I guess it's going to work. Yes, so also actually we need to have a new line after at the end of the outer loop. We need to print this out. And here we go. So all of what all we just did is just we removed for the first iteration of the outer for loop. We just subtract the value of I, which is for the first iteration it was 0, so E minus 0 it will still E, so it will print the whole all the letters. For the second iteration, E minus I is going to be 1, so E minus I it would be the letter D. So we will print the letters from A to D, and so on. Last question, question 7. Write a program that will display the following multiplication table. So this is a multiplication table from 1 to 9. Here is the multiplication, the product multiplication between 1 and 1, and it ends here with multiplication of 9 by 9. So for this, to complete our mission, we need a nested for loops. So let's have the outer loop here, and I equal 1, I less than or equal 9, and then I plus plus, and then for and the inner loop, and j equal 1 and j less than or equal 9, j plus plus, and let's print out the product of both index. So system.out print line, let's have I by j, and so we got all the production, all the multiplication, but in one row. So let's organize that a little by just adding by just printing a new line after the inner for loop. And also just and remove the new line from here. Also here we get all the multiplication, but we need to add spaces between the numbers, so we just add concatenate as space here after the number. However, it looks like it's not in the same in the right shape, because these numbers has only 1 digits. However, other numbers has 2 digits, so they are not in the they are not in the same column. So to solve this, we might concatenate two spaces before the number if it is less than 10. So if I by j is less than 10, that's mean it has only one digit. So we, instead of having one space, we have two, 1, 2, and else we add only one space. So we run that, and as you can see, we have the same multiplication table as in the question.